Okay, so first of all, you have to set all the files in the same directory as it is. Like I have sent you three files: ml.ipynb, the model mlpipeline.pkl, and the source code, that is source src.py. And then open them all. Open the complete whole directory in the VS Code like this. As you can see, these all the three files fall in under the same directory: the ml.ipynb, source.py, and the pipeline.pkl. All of them, the three files are under the same directory. Now, let me walk you through the machine learning part. First of all, I have loaded all these necessary packages. For you to load these packages, you have to first install them by using, let me show you. For example, I have to install pandas. You have to do pip install pandas. Okay, this way you have to download and install all these packages: pandas, numpy, seaborn, matplotlib, all of the mentioned packages. And then we move on with further analysis. I have set the settings to show me all the columns. I think there were 43 or 50 columns in this data set. So it's the like a lot of columns. So to watch them on the same screen, I had to set the settings to display maximum columns. Then I went on to load the data using pandas, and this is how the data looked like. Then the first step was to check for the missing values, and then later on I went on to impute those missing values. I set the threshold to 30%. If a column contains more than 30% of missing values, then drop that column. Okay, and then I assured that there is no missing values. What if there were some missing values and I wasn't able to see them? So to make sure that thing, I imputed the missing values. For the numeric ones, I replaced the missing values with the mean of values. For example, like as you know, if we have some numeric values, then in a column, for example, it is age, and some values of age in the column are missing, then you take the mean of all the values and you simply replace those missing values with the mean of ages. And for categorical, most of the columns were categorical. So for categorical, we use to fill with the most frequent values, that is actually mod. Okay, and then I visualized how my data looked like. This was the distribution of readmissions, and there were three distributions in start: less than 30, greater than 30, and yeah, and simply no. So for less than 30, I named it to probably. For greater than 30, I named it to most probably. And same goes for I did it with respect to the age groups, and this is how it goes on. And then comes the point to the feature selection and feature engineering. So for feature selection, I opted the setting for checking the correlation analysis, like how correlated a feature is with label the target column, the target feature. And again, I had the issue with the categorical columns. So for there was separate correlation analysis for numerical as well as the categorical columns. You can look into this. All right, and then here I mentioned all my categorical columns, and I used Cramer's V. I just simply defined a method to calculate Cramer's V, and then I checked all the correlation values, and I simply dropped off those columns having correlation less than zero point 0.1 with respect to the target column. This is not the correlation with, for example, the correlation of the feature A with the feature B. This is the correlation of feature A with the target column with label. keep in mind. And then I went on to the data segregation part. Segregation means to split the data into test and train set. Again, for that, I had to import all these packages, all these methods from scikit-learn basically, and all of these like train test split, the one hot encoder, standard scalar, all these can be imported via standard scikit-learn. So you just simply have to install scikit-learn like this, pip install scikit-learn as I told you earlier. All right, and after doing that, I had to select my columns. After selection of the columns, I went on to these three features: diagnosis 1, diagnosis 2, diagnosis 3. These were under categorical category, and then I decided to, like, these were numbers, not categorical values, so it was some error from the users. So I had to typecast them to the numeric ones. So afterwards, these were all the numeric columns, and this is how the data looked like. The diagnosis one is now flowed. The only categorical columns we were left with are examide and cytoglycan. And now, as you see, we are left with only 6 or 7 columns. We dropped off all those unnecessary columns based on the correlation analysis. Keep in mind. And then I went on to the exact segregation of the data. I kept 20% of the data for testing and 80% for training. And here I created a pipeline as there were some unknown values in diagnosis 1, 2, and 3. So I just simply set it to ignore them. Okay, we can in further studies we can also find a way to impute them in some way. Okay, now the the model training comes into picture. We simply created a pipeline, okay, and in that pipeline, the first step we defined to use that preprocessor. This is actually transforming the columns. For example, as you know the scaling and the one-hot encoding. Encoders are used for categorical columns. Let's say we have 5 to 6 values, for example, good, worst, or very good or excellent. These are 4 to 5 categories. The machine learning algorithms unfortunately do not take that in, so we have to give them some numerical values. So we have to do some one hot encoding or label encoding depending upon the situation. And for those numerical values, the values can fall from 0 to infinity, right? So for that, scikit-learn provides us the standard scaler to scale those basically. Okay, now I created a pipeline. The classifier I chose was logistic regression. Okay, this was the machine learning algorithm. Then I simply fit my training and the testing, my training data into the pipeline. It was trained, and I saw its accuracy. It was 65%. Then I went on to see the classification report with all the metrics, precision, recall, weapon score, accuracy, and then I had to visualize it, and I chose confusion metrics, and then I simply saved that model as ml pipeline.pkl. So this was the complete analysis part of the data and saving the model. Now in the next step I created, so let me show you the model. This is the model we saved, this one, ml pipeline.pkl. You can see it here. Alright, and then I went on to create this src, that is the source code for the desktop GUI app. I defined a class. Yeah, and for this one also you have to install this package pyqt5. We have multiple options in Python to develop the GUI applications, and I chose PyQt